Please pause the video and take a moment to read this important safety message.
All right, should be a fun video here today at Blue Glow Electronics. I'm going to kind of do this in two parts. One, a little bit of classroom style. Then two, we're going to go over on the bench and actually replace a can cap. So you get both the kind of the educational side of it as well as the practical side of it. So what we're focused on today is how to replace electrolytic can capacitors in vintage gear. And I don't care if this is a tube amplifier, an old television set, an old computer. The things I'm going to teach you today pretty much apply to anything that uses this style. As you can see in the picture here, electrolytic can capacitors. All right, so a few basics. Back in the day, these can style capacitors were highly effective devices. You could basically take the majority of the capacitors in a given power supply, bundle them all up into a single can and mount it on the chassis and not take up a lot of space underneath of your chassis. And this was common in lots of your old vintage tube gear, okay? Today they would just simply have a circuit board with holes drilled for a couple capacitors. They'd drop them down in there, solder them, and it wouldn't be a big deal. But so you don't see these used as much today as you once did. But they're still highly effective devices, and as we go to restore vintage gear, we want to know how to replace these units. So if we take a look at this capacitor here on the right, it actually has what I would call 4 sections to it. It has a 20 microfarad section at 475 volts, and that is indicated by a D, okay? And if you come over here and look at the bottom on this tab, you'll see that this little tab right here has a D to it. It has another section, 20 microfarads at 475 volts at a square. This one would be your little square connection here. 20 microfarads at 475 at a triangle. You've got that over here. And then this capacitor actually has another section, 20 microfarad at 475 with a dash. The one I'm showing the picture of down here only has 3 sections to it, but the 4th section would be right here. So you kind of get how you correlate between the bottom of these units and the side here of the can. One thing to note about electrolytic can capacitors is they typically have a common point to these capacitors, which is the can itself. And in this case, so you'll say, okay, this 20 microfarad here at D, and you'll get D. Well, one side of it would connect here, the other side would connect to the can. One side would connect here for the square, the other side would connect to the can. And it doesn't matter which of these 4 tabs here you connect to, they're all tied together as part of this larger outer can, okay? And one thing to note here, this one just happens to have the same values throughout all 4 sections. This could have been 20 microfarads, 60 microfarads, 80 microfarads, and the voltages for each could have been different. So pay attention to that when looking to replace one. And then the last thing is make sure your can height, that is important. And when I say can height, I'm kind of talking about the delta between where my cursor's at right here, where it would mount against the chassis, and the very top up here. Because the last thing you want to do is order one of these can caps, and they can be expensive, $30, $40, $50. You get one of them, you mount it in, and you're like, wow, this is going to sound great. You turn your unit on, it starts playing well, and then all of a sudden you go to put the chassis back on it, and it's a 1/4 inch too tall. So can height is something to pay attention to, and make sure you get something equal can height or shorter when replacing a unit. All right, the next thing we need to concern ourselves about, is it a hot or a cold can? And you may say, what are you talking about, Mark? Well, remember a minute ago I showed you that, and what we were describing was a negative grounded can scenario. In other words, the outer part of the can here is ultimately bolted directly to the chassis. So the can itself is at the same potential as the chassis. Typically these will have no cardboard on the outside of them. And the can tabs tie directly to the chassis, to the ground of the chassis. And in this case, it is okay to touch this can because the can is at the same potential as the chassis, which would be ground, and there would be no issues. There's another scenario you will see, what is just called a hot can scenario. Typically the can is covered in some kind of cardboard like you see here. This is a Fisher, I think, 480 console stereo unit here. And you notice its capacitor is not only covered in cardboard, so if you touch it, you wouldn't actually be touching the metal can itself, but it's also not mounted directly to the chassis. You'll see this little kind of fiberboard phonic insulation material here that is insulating the common parts of this can from ground. And I'll give you a good example. Like on a Macintosh MX110 or whatnot, they've got a can capacitor on the back that is covered in cardboard like this, and it sits at around 90 volts. So if you were to happen to touch that can at 90 volts and your other hand would happen to touch the chassis, you're going to send 90 volts through you. And it could be more than that. It could be screen voltage, 225 volts or something even higher. So you'll notice here I say it is not okay to touch the metal raw can, as it is at some voltage other than ground, and you will be the short to chassis between your right hand here and your left hand that touches this or whatnot. So you need to pay attention to this when you go to replace a can cap, and make sure you order one that's covered, and make sure you got a proper kind of fiber mount board here if the one you're trying to take out breaks for some reason. You want to put these back the way they came. You don't want to drop in a can cap in here and just leave the outer part of it here uncovered. It would not be good for you. All right. There's a couple different approaches you can take in replacing these, and I'm not saying this is an all-exhaustive list. It's just the most common list. And I have ordered these in order of what I would recommend down to what I would least recommend, and that's just my personal preference. You can take that with a grain of salt. But the first one up here would be an exact replacement. In other words, you find a brand new can capacitor that was made recently, that happens to match the exact same values you need. The height and the width fit, and you're able to put that unit in there. And let me show you here how you might go about doing that. Okay, I'm out here on Antique Electronics Supplies website, and you can scroll down here and you'll notice under capacitors, you'll notice multi-section can type, and you click on that. And all of a sudden you start seeing lots and lots of different types of can caps pop up that might fit your exact needs. And Tubes and More has some of those that are very commonly found in various pieces of electronic gear, that vintage gear that's being restored. So you've got just pages and pages here to scroll through of various sizes. You can get these mounting plates. This is a metal one. I think they had back on the other page. Yeah, right here, your little insulator. So if you happen to chip these crack very easily when taking the old one can caps out. So you might want to order one of these to replace it with. But you get the idea. You can come out here and pick some of these types. Like I use these a lot. This 32, 500. But you do end up having to get a mounting bracket to either go above or below the chassis to kind of hold them in place. Whereas if you kind of get an exact replacement, it'll have tabs on it here that'll mount back in exactly like the original. And there are a lot of guys that sell these on eBay. They also sell kits. Let me show you that. So like if you had a Macintosh 225 amp, you can see people here sell kits that have a can cap in it, and the other two can caps. And if you notice, these are coated on the outside because they might be used in a scenario where the can is not at ground here in this case. So you can get them in sets that might match your exact gear you're looking for, or you might order them discreetly like this and build your own kit. All right, the next step would be to get an exact replacement. If you can't find the values you're needing, you could have a custom cap made for you to meet your original specs. Now, a few years back, this would not even have been an option. It might be slightly more expensive, but I'm finding not a whole lot. But it's a very viable option these days thanks to guys over at Hayseed Hamfest. And let me show you that. Okay, and if you come here to Hayseed's Hamfest, click on Audio. You could come down, like if you've got a piece of Fisher gear, like right now I've got a 400 CX2 that I'm wanting to recap. I could order a can cap here. It comes with a couple different cans, a 1000 at 35 microfarad, another 1000 at 30 microfarad. And if you'll notice, they're upgrading the specs a little bit. They're going a little higher on the voltage. We'll talk about that. But you can see that's in can number 1. Can number 2 is 40, 40, 10, 10. and they're putting it back at 40, 40, 10, 10. And then in can cap 3 here, 30, 30, 10, 10, and they're going back at 30, 30, 10, 10. They're upgrading the voltage here along the way. That one was at 300, now it's at 350. And we'll talk more about that in a minute. But if you don't have what you're looking for on here, you can always come over here and click Request a Quote and CAN Capacitor. And then you basically tell it which kind of base you've got, 4 tab here. And then it walks you through filling out your name, your address, the piece of equipment, selected height. Remember I told you how important that was? So I'm working on an ICO HF85 right now. I went in and filled all this out. I clicked submit. They came back, and it was basically $30 for the capacitor I needed, plus shipping. So I think I had $37, $38, something like that in the capacitor. Not a bad deal at all. And up here it says their current lead time is presently running between 5 to 10 working days. So it's going to take you 2 to 3 weeks to get one of these likely, which, you know, if you're not in a hurry, it's not that big of a deal. But it's a great option. Did not exist a few years ago. These guys will custom make you just about anything you want, and it's a wonderful service for us to have these days. Okay, and our third option here is an increased value replacement. In other words, you're doing either the first one here or the second one, but you're increasing the values, and I've got a whole slide on that here in a minute. And up next, you can use standalone axial or radial capacitors to make a bundled package equivalent to the original capacitor, and then leave the original can cap in its place and mount this other little bundle you've made under the chassis. And I pulled these out of some older videos I made. Here was a firecracker style multi-can cap here that had really 4 different caps inside of it. And what I did was I ended up taking these 4 and I put them together, and I tied all the grounds together, and I made this nice little bundle that I was able to mount inside the chassis then. And then I was able to run my wires off of each of these positive leads here. So that's a good way to go about, you know, if you don't want to spend the money on a can cap and you just happen to have the values laying around. Typically the deciding point for me on this is how original am I trying to keep the gear, and how much space do I have underneath the chassis. This is certainly a less expensive option than the can cap, but the can cap is likely to keep your gear closer to the original, the way it came. And our next option here is kind of a variation of the previous one here. What you're actually doing is, in some way, shape, or form, you are gutting out the original can capacitor. You can see here somebody actually cut the can top off, and they've gone in and gutted it out. Now they're putting it all back together, and they're going to glue this can top back down on here, okay? It's a great way to go about it. It keeps it looking all original. It is a good bit of work, and not always does it work out so well that they fit in there like they did here. Sometimes you end up having to order maybe skinnier capacitors than you've got on hand or whatnot. But it is a viable option, especially if you're trying to keep a piece of vintage gear looking exactly the way it came from the factory. And then the last thing here, and this is the one I would recommend the absolute least, is to find a new old stock exact replacement. In other words, you go out on eBay and you search for 40, 40, 20, 20 microfarad can capacitor, and up pops a Sprague unit from 1967. And you say, woohoo, it's exactly what came in my radio. I'm going to order it and I'm going to put it into my unit. Well, here's the problem. Capacitors dry out. All of these can caps at this point in time are 40, 50, 60 years old, okay? They dry out in a new old stock box the same as they dry out in your piece of gear. So you may put something that's new old stock out of a box into your gear and be in no better shape than you currently are in right now. So don't recommend this path, but it is a viable option I'll put on here. All right, and then some general rules around changing the value of your capacitors as you replace it. First and foremost, stay as close to the original value as you can. They designed it, whoever designed this piece of gear designed it with these values for a purpose. Try to stay as close to that as you can. However, if you have to make a choice, and often you will, because the standards for component values in the 1950s do not match the standards for component values today, okay? If you're going to have to make a choice, go higher in microfarad value, but try to stay within the next range of capacitance. In other words, Let's say your can cap has 30 microfarad and you're going to replace that with a discrete capacitor. You would want to go to 33 microfarad because that's a standard value for today. You don't want to jump up to a 47 microfarad. You may overtax the circuit just depending upon its design. Okay, so if you have a choice, go higher in microfarad, not lower, and try to stick within the next range of common value. So 30 to 33, not 47. Or if you were replacing a 40 microfarad, use a 47 microfarad, not a 68 microfarad. Okay? If you are going higher in microfarad value, and this is very important, look at your schematic for this piece of gear. If the piece of gear is tube rectified, and it happens to be using a CRC or CLC type of filtering after the rectifier, which is almost always the case, okay, go look up the tube data sheet. This is a tube data sheet right here for a 5U4 rectifier, okay? Look for something in the value here called the filter input capacitor typical value. So what it's telling you here is the first capacitor following this rectifier in the CRC or CLC chain. It's the first one we're worried about, not the second one or the third one or the fourth one. The first one needs to be as close to this value as you can get it. So if you were replacing something here and it's 40 microfarads, try to stick to 40. If you have to go 47, it's probably okay. It just could shorten the life of your tube over time. What I would not do is replace a 40 microfarad here with a 68 microfarad or 100 microfarad. A lot of people get all wrapped in their head around more capacitance is more storage, thus more kind of instant on demand, as needed power from your power supply. And while there's some truth to that, it's not worth overtaxing your components. And tube rectifiers are one of those devices that care greatly about the first capacitor after the rectifier. So on the second, the third, and the fourth, if you want to bump up even more, you're probably okay. The first one you need to stick as close as you can. And then this next statement, it is always okay to go with a higher voltage rating on a capacitor. Just do not go under. So if you had a capacitor that's rated at 10 microfarad at 300 volts, it's okay to replace that with a 10 microfarad at 400 volts, 10 microfarad at 500 volts. It just means the capacitor is going to run cooler over time and have more tolerance to its specs, and you'll be fine. But if you take a 10 microfarad at 300 volts and you try to replace it with 10 microfarad at 200 volt capacitor, and your unit happens to be operating at around 250 volts all the time, the life of that capacitor is going to be greatly reduced. It's going to build up heat, and it's ultimately going to end up shortening the life of that capacitor. So always okay to go with higher voltages on a capacitor, not okay to go under. All right, so what I've got here is an HF85 ICO preamp that a customer sent me, and it's not in the greatest of shape. It's kind of old and got some pitting and whatnot, and the customer's not wanting to spend a fortune on it, but he is wanting to get it working and functional. So I told him, there's a couple different paths we could go down with this. There's just kind of get it working, and then there's all these upgrades and enhancements you can do to these, and he just wanted to kind of get it functional. So my plan's really to deox it and clean all the switches, to replace this can capacitor, and then on the other side there's a lot of old vintage original coupling caps here, as you can see. So let's start out here with this can cap, and if I'll notice on the side of it here, let me see if I can zoom into this, and I know you're not going to be able to read it, but you can kind of see here, or maybe you can. There is 20 microfarad at 400 volts. There is 40 microfarads at 350 volts, and another 40 microfarads at 350 volts. So it's a 3-section can cap here. And if we kind of flip it over here and take a look at the other side, you'll see the 3 tabs here, 1, 2, and 3. And then the common negative, as I showed you earlier. If you'll notice, some of these are tied off to on the side here, and they actually soldered this one to the chassis. It's kind of hard to see because it's hidden underneath this resistor here, but you can barely see it down in there. And so they've tied the can to the chassis, and then they're tying off all these resistors that are part of this power supply dropping circuit here as we go. So here's the challenge I had though. If we flip this unit back over, and if I was to, let me zoom out here. Whoop, wrong way. If I was to lay something across the chassis here, I don't know if you can see it there, but I've got like 3/16 of an inch to play with. There's less than 1/4 of an inch spacing between here. And as I started looking up replacement caps on Antique Electronics Supply, eBay, and other places, I could not find one. Every one I found was a 1/2 inch taller than this. Thus, the original chassis cage cover would not go back on the unit. So I went to Hayseed Hamfest website and I filled out the paperwork, the page I showed you where you fill out kind of what you want. And I ordered one and I got it. And then I got to measuring, and lo and behold, they put a cardboard cover over this one. I'm not sure why, because I had specified can being the common negative here, but they put a cover over it, and it made it too high. It won't fit. If I would mount this in there, I would still have the same coverage gap, mainly here because of the thickness of this cardboard. So I sent them an email and said, hey, I'm still having a challenge. And he said, wow, I didn't realize that they had put this cover on there. And they're actually glued on. I asked if it was easy to get off, and he said it's not. And lo and behold, about 3 days later, in my mail shows up another capacitor. So they sent me one with the without the cardboard on it, and now it is exactly the right height. If you flip that over and put it all the way flush, you'll see here I've got the exact height here, and we'll be in good shape. So now we've got 20 microfarad at 400, 40 at 350, 40 at 350. They made one identical to match this. Although this was a 70 degrees Celsius rated cap, this is a 105 degree rated cap, which means it's going to run even cooler and stress even less. So let's go put this unit in. Okay, up next, a couple practical things from years of experience, okay? Get a close-up picture of what you've got going on here, and also get you a little further away picture here that shows all the wiring and whatnot, okay? You may come back to that later. Pictures are worth 1,000 drawings in some cases. But what I've done next here, and let me zoom in on it. All right, here we go. You can see now, I've drawn this unit out here just using, I basically drew the square that's in the chassis that's cut out. I put the 4 tabs here that are kind of connected. And then I kind of drew in, hey, there's a 220k ohm resistor here between this outer tab and this first one. And I drew the little symbol here that is the triangle that's actually on the capacitor over here. You notice this one's the square and this one's the kind of half moon shape. So I've got a 220 ohm resistor between that tab and this tab. I've got a 68 ohm resistor between these two tabs, and I had a 10k ohm resistor between these two. And then there was a 2.2k ohm resistor that kind of came off of this tab and went over to the 6x4 rectifier. And then there were 3 red wires connecting to this unit. There's one feeding over here, there's another one coming in here, and a third one that comes in here on this same tab. And let's go take a look at that if we can. Okay, you can see here is that 220k ohm resistor here between this tab and ground. There's the 68k ohm resistor between those two tabs. There is the 10k resistor between these two tabs, and over here is that 2.2k that feeds over here to the other rectifier. And as you can see here, I have labeled these. I have taken just a little label sheet like I use for labeling tube boxes, and I just cut a little piece of sticky label and I labeled this one 1, this one 2, and this one 3. Just like on this paper here, this is red number 1, this is red number 2, and this is red number 3. Now I have both a picture of everything, and I also have a drawing of everything and where it goes. And the reason that's important, too many times I've gotten in the middle of replacing something like this, and your kid needs you, or your wife, or whatever, and all of a sudden you leave and you go away and you come back 2 or 3 hours later or the next day and you're looking at it and you're going, I don't remember where this red wire went to. And then, like I said, if you didn't have a picture, if you didn't draw it out, you wouldn't know. So once you've done those things, then you can go in and let's desolder and remove these components. All right, I have seen some people do an interesting trick before. What they do is they take all the wires going to a given tab like this, and then they come down here at the bottom and they clip the tab off at the very base where it goes into the capacitor. And they leave all those soldered connections together, and then they just solder this tab onto the tab of the new capacitor. I'm not a big fan of it myself, but functionally seems to work okay. Could be a path you might want to go. Okay, as you can see, I've gotten everything disconnected at this point. And if you zoom out, a little bit, you can see I've kind of got the wires just kind of hanging now with these leads colored. Now, if it's me, the reason I go ahead and just cut stuff loose versus desoldering it is I'm going to go ahead and replace these resistors while I'm at it anyway. The two of them are carbon comp resistors, likely to have drifted in value over time anyway, and it's about as cheap for me to replace one of them as it is to spend the time desoldering it properly. So I actually just, as you can see here, I snipped these out, and I'm just going to replace it with new resistors as we go. The wire ends, the same thing. I just snip them off, I'll strip them, and I'll solder them back down. Now at this point, what we've got to figure out how to do is how to get this can cap loose. If you will pay close attention here, this tab does not have any solder on it. It's just twisted a little bit, and we're going to twist it back straight. Same with this tab, no solder, just got to twist it back straight a little bit here. Sometimes this doesn't always work out. Third one here, same scenario, and these things here are kind of in my way in the middle of doing what I'm doing, so I'm just going to bend them over. Similar scenario, let's get that one straight. And then the fourth one here. Not only is it twisted, but it is also soldered as well. So I'm going to try to twist it back up straight while I hold it from the underside here, while I apply heat here to the to where this thing's soldered. And I may have to get out a heat gun. Sometimes soldering iron just does, not heat gun, but a soldering gun instead of soldering iron here. But what I'm going to do is heat it up here, get this good and hot while I wiggle from underneath and try to pull this capacitor out. Another path you can take is you can grab these and just twist them kind of back and forth with a pair of pliers. Let me zoom out a little bit. I keep zooming the wrong way. You can grab it and just kind of go back and forth until they snap off. That's an okay approach too. I will tell you, this is mounting to the metal chassis. That's easy to do. When you're mounting to one of those little fiber discs, that twisting method is really easy to break your disc that's mounted into the chassis. All right, all I really had to do was heat it up over here. I did find there was a teeny drop of solder right here on this side, but I just kept working it a little bit, heating this, heating that. I was able to do it with the Heiko iron. I did not end up having to get out a soldering gun. But as you can see, we've got the old unit out now, and it's just a matter of let's get the new one in there. Okay, one thing you're going to want to make sure before you jump to the next step and mount this in there is on this one, the 20 microfarad at 400 volts is the little half moon. And it just so happens to be 20 microfarad is the half moon on this one as well. And then the 40 and 40 are the square and the triangle. But it may not be the case. It could have been that the the 20 here was a square, and if so, I would have needed to kind of change my reference point here and change that symbol as I go to mount it back in. But we should be good to go here, just mounting it back in identically to the other one, the way that one came out. If you'll notice here, in this corner over here is the half moon, and this back corner here is the square. So I'm going to put it in here so that the certainly the half moon is over here and the square is right here. And so we just then feed it back up over into here. And we may have to work a little bit with the solder here to clean up this little spot right here first. All right, there it is. It's mounted up in here. And now what I'm going to do is similarly to what they had done before, I'm going to grab a couple of these and twist them and lock them. That's why these are called twist lock can capacitors. I've grabbed 2 of them now and locked them, 3 of them and locked them, and then this 4th one I'm going to lock it as well. And then we're going to solder this 4th one back down so that's grounded to chassis. And this unit's in there good and solid right now. Okay, we now have it soldered in. We've got our 220K going here. We've got our 68K going here. Got our 10K, and I put in a 3 watt resistor here, or 2 watt, I'm sorry. These are all 1 watt, 2 watt. And then you've got the original 2.2K. I didn't change it out going here. And I've got wire number 1, wire number 2 here, and wire number 3 all feeding in. The only thing I did different than my picture shows is originally this 220K came off the triangle and went over here to this lug. Well, this lug didn't have a hole in it, but yet this one did. And remember, this whole can's at the same potential. So instead, I brought it over here to one of the lugs that had a hole in it. And I did make sure I soldered it to the chassis just to give it the shortest path to ground there possible. And we've got the lugs all soldered down at this point. Let me flip it over and show you. All right, all soldered back in. As you can see, it actually looks better than the rest of the unit at this point. Really good looking capacitor mounted in there, and I've got plenty of clearance here for the cage to go on top. So, all right, that is how you go about replacing a can cap in a piece of vintage equipment. Didn't matter if it was a TV, a stereo, a computer, whatever. The process is going to be about the same. You're going to go through the same considerations. Hopefully this made sense to you, and stay tuned. We'll make some more videos like this. Thanks for watching, everybody.